to my new course at Boost Knowledge, IGCSE Physics. But you might ask, why have you just updated like the first time in like 6, 9, 10, 12, 100 months? The reason being I always had exams concerning physics and science and other stuff, so I couldn't really update. But concerning the fact that I've just received from the combined support of all of you viewers and subscribers 1 view on my channel over the past 30 days, I've decided to actually start something new, start some new playlist which will probably attract some more views and subscribers. But I'm not just doing this for the clickbait, not just doing this for the views and not for the subscribers. I'm actually trying to make physics fun for you guys. Because I myself have been pretty bestrangled and confused by the concepts and equations from IGCSE/GCSE physics, but this course is built to be not boring. I'll go through the concepts and equations with you and you will have to learn them, but I'll show you them in a way which makes our real world interesting and fun, and that you can learn these knowledge well and use them in your exam well, and enjoy a good day watching YouTube. You're welcome to watch any of my videos on my channel. What's more, let's get started. So in our first lesson, we'll be covering the 3 terms and definitions: speed, velocity, and most of all, acceleration. And you're not probably thinking, I know all these things. I'm not a 3-year-old. Wait, let us rewind a sec. Let us rewind. Speed, velocity, and acceleration. So I think, because you guys are probably GCSE students, and not some random 1-year-old who has just gotten a new iPad and walked onto YouTube and opened the first video which YouTube algorithm showed them, although I only have 68 subscribers for some reason. I think at this stage of GCSE we all know that speed is distance divided by time, velocity is displacement divided by time, speed is a scalar quantity, so it only has a magnitude, velocity is a vector quantity, so it has both magnitude and direction. Speed, distance, is the total distance traveled for an object, while displacement is the net distance traveled, so displacement can be 0 and average velocity is 0, that's why it's not used, but okay, let me explain it. Because the entire point of this course is for me to explain everything clearly. As we all know it, speed equals distance divided by time. And you're like, I know that. If I am walking 50 meters and I do it in 10 seconds, my speed will be 50 divided by 10 equals 5 meters per second. Likewise, if I go the same 50 meters, that's not 50 meters, in say 100 seconds, then my speed would be 50 divided by 100 equals 0.5 meters per second. That's the SI unit for speed. And you're like, that's easy peasy lemon squeeze, so let's move on. Velocity, defined normally as displacement divided by time. So, going back to example, say if I was walking the same 50 meters and did it in, say if I was doing the 100-meter race and did it in 300 seconds, then my speed would be 100 divided by 300 equals 0.3 meters per second, and somehow finishing second to last place. But you might ask, velocity and speed, they're the same, right? Unfortunately, they're not, because velocity is a vector quantity, while speed is a scalar quantity. What is a scalar quantity? And velocity, what is the vector quantity? If you didn't quite catch me at the beginning, a scalar quantity only has magnitude, while a vector quantity has both magnitude and direction. So say I'm walking uphill at 5 meters per second, that would be my speed. But say I'm walking downhill at 5 meters per second, that would be my speed. Say I'm going up on a hot air balloon at 5 meters per second, or dropping down a well at 5 meters per second, although air resistance is not able to slow me down so much against free fall, which brings me down, means this is not possible. That would only have the magnitude of 5 meters per second. But for velocity, say I'm going eastward at 10 meters per second, that would be 10 meters per second. But say I'm going westward at 10 meters per second. What? No. Negative 10 meters per second. And that's how your speed can be negative. No. Your velocity can be negative. Furthermore, you might ask, can we make this positive? Because I really like going left. Well, you could. Linking up perfectly. You could do whatever way you want, and often it is indicated by this symbol on top of the V, indicating which direction you want to go to. Easy peasy lemon squeezy. So let's go down to displacement versus distance. As you can see, velocity is displacement divided by time, and speed is distance divided by time. So distance is a scalar quantity, and displacement is a vector quantity. What is their difference? In displacement, do you get displaced, or what the difference? Well, say I started off at London King's Cross station, took a Great Northern train to Finsbury Park for no reason, walked down 10 million stairs and took the Northern Line to Northampton Central, walked out, took the Overground down to Gospel Oak, changed trains, and took the Overground, another line, to Finchley Road, walked out for a long time and took the Metropolitan to Baker Street, walked out, changed the Bakerloo line to Oxford Circus, walked out, took the Victoria line to King's Cross and Bancroft, walked out, and walked back into the National Rail Station. Congratulations, I've just travelled a distance of around 30 kilometers. Correct me if I'm wrong. I don't use the underground a lot. But my displacement, say I started at platform 0 and ended at platform 0, and yes, platform 0 does exist at King's Cross Station, my displacement would be 0 meters. 0. I could run around the earth, start at the same point, end at the same point, my displacement would be 0, because I would be displaced by 0 meters. Think about it. The total upwards distance I've travelled is equal to the total downwards distance I've travelled. The total eastwards distance travelled is equal to the total westwards distance I travelled, and therefore the displacement, if I've started at the same location and ended at the same location, would be 0, while the distance would not be. Which is interesting, and we can leave poor me wondering why a watch says displacement equals 0 after I've ran an entire lap around North London. But let us continue here. On the topic of speed, velocity, and acceleration, because now we're going to define two definitions. Bear with me. And here we have the two definitions: average speed, and instantaneous velocity. Average speed and instantaneous velocity. Sorry, my handwriting is awful today. Can't spell. Average speed is literally average speed. Say I walk forward 10 meters in 2 seconds, stop for 20 seconds, and walk forward 10 meters for 5 seconds. What is my average speed through the entire journey? Well, my total distance traveled would be 20 meters. And my total time would be 2 plus 5 plus 20, which would be 27 seconds. So my entire average speed would be 20 divided by 27. The exact value I'm not going to calculate because I just made these figures up. And if you're wondering what the hell this is, that's a sigma sign, which means adding everything together, adding all these values, necessary values together. So that's the average speed. So say, although I moved at 5 meters per second here and 2 meters per second here, my average speed is less than 1 because this is less than 27. Average speed. And then we have instantaneous velocity. Instantaneous velocity is the very velocity I'm traveling at this very moment. The very velocity I am traveling at this very moment. So I could be, so if we plot the velocity time graph, don't worry, we'll cover that later. Sorry. Nobody's perfect. Say I'm cruising at this velocity and suddenly I go up and down. That would be, and if the instantaneous velocity is here, that would be my instantaneous velocity, say 30 meters per second. And my instantaneous velocity would be 30 meters per second, which is not possible, but forget that. Instantaneous velocity, the very velocity you're traveling at, 30 meters per second. But now you have a question. Why not say instantaneous speed or average velocity? Because it obviously makes sense, because they are speed and velocity and average and instantaneous. There should be 4 terms to describe this. Why only 2? Good question. But let's return back to what speed and velocity is. Speed is a scalar quantity. It only has a magnitude. So an instantaneous speed would confuse between going that way, 30 meters per second would be the same technically, speed wise, as me going, I can't draw, this way, 30 meters per second, which would be confusing because velocity wise they are not the same, because that would be plus and minus according to which way you look at it, because velocity is just better. It's a vector quantity and there's a direction, and these two are obviously not the same. Goodbye instantaneous speed, you were short-lived. But what about average velocity? At least if velocity is better than speed, why not average velocity instead of average speed? Well, firstly, it doesn't matter which average speed you're going at because it doesn't matter with the direction. And secondly, back to the example. I said that what King's Cross and Pancras got different back, got the bottom of the central, got the cross by can go to Infantry Road, and go back to King's Cross and Pancras, and my velocity is equal to displacement divided by time to my velocity, as displacement is 0 would be 0. What? But it moves at a speed, the trains are quick because it's called average velocity. But it was 0. It's 0 because this stupid displacement thing is 0. So I could run around the whole track and my average velocity would be 0. Doesn't matter how quickly I run. Everybody is the same, from Usain Bolt to like the slowest runner in the road. As long as they can do a lap, their average velocity is the same. But for average speed, it would not be the same because speed doesn't head and care about displacement, and therefore the speed can never be 0 unless you don't move for the entire race. So goodbye average velocity. You are indeed very confusing. Goodbye. So we've just debunked lots of speed and velocity and distance and displacement problems. let's continue. How to measure speed? Because there's no there is a speedometer, funnily enough, but say this pencil is going out at this speed, how can I measure it? Or say I have this new George Orwell book going for us at this speed, what is its speed? Well, this is what you would say. Let's say this notebook has a length of, let's just make it up, 20 centimeters, and I get a stopwatch out of nowhere and realize that if this book travels travel from the start of the 20 centimeters to the end, to the second the start point touches this part of the 20 centimeters, this would be its speed, or at least average speed, or anyway velocity. But humans have a very bad reaction time. As you can see, me trying to pilot my little watch, I'll click at the same time. 0.11 seconds is impressive, but there will still be an error. And if there's an error, it cannot be accurate. And say I get distracted, it gets longer. Or say I am drinking alcohol, or I misclick, the time gets much longer. And this way, using a simple stopwatch and ruler, it's just not that reliable enough. At least for the stopwatch part, rulers are fine. But how can we measure speed or velocity accurately? Is there no way to do it? Are stopwatches out of date? Fortunately, stopwatches are not out of date. You don't need to fear that, because we still need them. But there are better ways, maybe more expensive, but definitely better ways to measure speed and velocity. Let me introduce them. The first one is called a light gate. A gate of light. But that's not what a light gate is. A light gate looks something, and I know my drawing is awful, but I hope it does look like this. Something like this. And that's the gate. And that's the light. But often you don't see the light. Why? Because it's infrared. And you don't see infrared, you only see visible light in the electromagnetic spectrum. I think that's coming up in another class. In another lesson, I mean. An infrared ray is at the gate of the light gate. Now, let us introduce you to the car, or little thingamajiggy, which is moving forward at a certain speed. And now we have one light gate on top of him, the light gate of doom. How can we measure its speed or velocity? Probably add a stick here, and then when the light gate comes, boom, it'll pass through, I mean, like this is the light gate. It'll pass through, and the time will be recorded, record the diameter of the stick, everything done. However, everything actually does have an error, a reaction time error. Infrared rays can't do it perfectly, it can do it better than humans do because it's not drunk or anything, but they all obviously will have an error. Increasing the contact time of the interrupting thing, which in this case is the stick, will be better. So humans invented this thing called an interrupt card, which is placed on the truck, and the second the interrupt card touches the light beam, which obviously it doesn't, but sorry, the timer starts, and when it finishes, the timer will end. The length of the light beam, sorry, the interrupt card, can be measured, and then we can measure the time taken, and then we can use distance divided by time to get the speed, or instantaneous velocity. But what about for average speed? Well, we know the instantaneous velocity of this thing, but what about the average speed? Sorry, what about the average speed? Well, multiply, get two light gates over here, But how would 2 light gates solve the problem? If the car is going to stop and move and stop and move and stop and move, why not just give it 2 light gates? And at this time you actually can use a stick because it's now useful. This car will start the timer, move leftwards, maybe stop, maybe move, and at the end of the day, it will finally reach the other side, and this will end the timer. The total time divided by this total distance can be measured, and thankfully enough, we can know the average speed, not average velocity. So, sounds very good, doesn't it? Well, let us introduce you to the second good friend, a ticker tape timer. I've not made this thing up. There's actually a thing called a ticker tape timer. And sorry, my handwriting is bad. A ticker tape timer basically punches holes in an object at regular intervals, which are normally 0.000. That's probably no. That's fat cap. 0.02 seconds is regular intervals. Around 0.02 seconds. Of course there will be an error, but normally it will be 0.02 seconds. This will be something like what the tape will look like, although I've done it in a very bad way. So let me do it in a better way. So what is happening in this tape? Well, at first, the object is accelerating. It moves at around a constant speed. Makes its speed quicker, and does it at a constant velocity. And probably I'll just change it to velocity. And probably this should be velocity. A ticker tape timer usually measures objects in free fall, which is an object falling to the ground. If the tape is tied to the object and the ticker tape timer is here, then the timer can accurately pinpoint to 0.20 seconds, and by measuring the distance between 2 dots, if it's, for example, a constant speed, measuring the speed between the dots, measuring the distance between the dots, say 1 centimeter, divided by the time of 0.02 seconds, will give you the speed. So smart guy, what will be the speed? 5, 4, 3, 2, 1. I mean, you can pause the video, but anyway, meters per second is the SI, not centimeters per second. And you don't get rid of the C or something. I mean, you don't. Meters per second. So that will be 0.01 meters over 0.02 seconds, giving it a half meters per second, or 0.2 meters per second. So problem solved. We will understand how this ticker tape timer works, or how a light gate works. So I guess that's all what you need to know about speed and velocity. Wait a sec. What about acceleration? Well, acceleration is a topic we'll discuss next time, because it's probably been 20 minutes and you're probably bored anyway. Please subscribe and like the video, because we can get this course to update and teach you all about IGCSE physics, which is made to be not boring, hopefully. Thank you for watching.